Welcome to MR.Wanyoike Digital Learning Platform. Your presenter is Mr.Wanyoike, a chemistry teacher. In today's lesson, we are going to look on the mole concept. Terms used in this topic, we have the first one is atom and RAM. The second one, we have molecule and RMM. The third one, we have ion. That one is ion and radical. And the fourth one is compound and RFM. To start with, on to the first one here, that is the atom. And we are going to define atom as the smallest particle of an element that normally take part in a chemical change. Or in other words, we can define atoms as the smallest particle of an element that take part in a chemical reaction. On to the RAM, that is relative atomic mass. This refers to the ratio of the average mass of an atom of an element to 1/12 of the mass of one atom of carbon-12. On to the second term here, that is the molecule. A molecule refers to the smallest particle of an element that can exist separately. Or in other words, we can define a molecule as the smallest particle of an element which can exist on its own. On to the RMM here. Those are the initials for relative molecular mass. And this refers to the sum or the summation of all the relative atomic mass of all atoms that are contained in a given molecule. For example, we can have a molecule like nitrogen gas, and therefore if we want to get the RMM of nitrogen gas, should be calculated by referring to the RAM, that is the relative atomic mass of one atom of nitrogen, which is supposed to be 14. Then you multiply by 2 and the answer becomes 28. And therefore, the RMM of nitrogen gas become 28. Another example, we can look on ammonia gas, and the RMM of ammonia gas should be calculated as follows. The nitrogen is 14 and hydrogen, each one is 1. Then you multiply by 3 because there are 3 hydrogen in ammonia, and the answer you will get 14 plus 3 and you'll get 17. And therefore relative molecular mass refers to the sum of the relative atomic masses of all atoms that are contained in a given molecule. On to the third one, that is ion. We can define ion as a charged particle, and therefore we have two types of ions. We can go to the types of ions, and the first type of ion is referred to as a cation, while the second one is referred to as an anion. And therefore for a cation, this is the positively charged ion, while anion is a negatively charged ion. And for the radical, this is a term which is used to describe a group of ions that react as one unit, and therefore a radical is a group of ions that react as one unit. On to the examples of radicals. I can come up with examples of radicals here. And the first example, we have hydroxyl ion. It is written that way. And the second example of radical, we have nitrate, and the formula for nitrate is written like that. And we have sulfate, that is another one. Sulfate is another example of radical. We have sulfite, Another one, we have ammonium ion. Ammonium ion should be written like this. It's written like NH positive, and you can see that there are those radicals which are negatively charged, while other radicals are negatively charged. So we have a positively charged radical and also a negatively charged radical. And remember, I've defined radical as a group of ions that react as one unit. Onto the compound. What is a compound? A compound refers to a pure substance which contain one or more elements which are chemically combined. I repeat again, a compound refers to a pure substance which consists of more than one element which are chemically combined. Onto the compound, we can have an example of a compound. Example of compounds. The first example, we can look at sodium hydroxide. The second one, we can look at calcium carbonate. Also, we have sodium sulfate, and the relative formula mass. The relative formula mass of these compounds is what we refer to as RFM. That is the relative formula mass, or the summation of the relative atomic mass of all atoms that are contained in a given compound. For example, if we want to calculate the relative formula mass for sodium hydroxide, you are going to calculate it like this. The relative atomic mass of sodium is 23, and that one of oxygen is 16, and that one of hydrogen is 1. And therefore, as you add all of them, 23, you add to 16, then you add to 1, and the answer becomes 40. And therefore, sodium hydroxide, the RFM of sodium hydroxide should be 40. And it will apply to the rest. The other example, for example, calcium is 40 here, and carbon is 12. You add 12, and oxygen is 16. You add 16. You multiply by 3. Why? Because there are 3 oxygen in this compound of calcium carbonate, and therefore the formula becomes 40 plus 12. 40 plus 12. Then you add to 16 times 3, and the answer becomes 100. On to the last one, that is sodium sulfate, and there is an omission of a valency of 2 here because sulfate is a radical and the valency of sulfate is 2, and therefore the formula becomes Na2SO4, and therefore the relative formula mass for sodium sulfate becomes 23. You multiply by 2, then you add that to that 2, then you add 16, you multiply by 4, and this becomes 46. You add to that 2, then finally you add to 16 times 4, and the answer becomes 64 there. And everything, once you get the summation of everything, you will end up getting the answer is 142. We have come to the end of today's lesson, and I'm going to highlight some of the very, very important things which we have already looked at. And the first one is RAM. And therefore, whenever we are looking at relative atomic mass, you have to consider only to the mass of an atom. When we come to RMM, we have to consider the molecule, the number of atoms that are constituting to the formation of a given molecule. On the other hand, when we come to the compound, that is the relative formula mass, we have to consider the relative atomic masses of all atoms that are constituted to that compound. Your presenters was Mr. Wanyoike. Till next lesson, bye-bye.